So here is another question. It is given a refrigerator converts 50 gram of water at 15 degrees Celsius into ice at 0 degrees Celsius in 1 hour. Calculate the quantity of heat removed per minute. Some information is given. Specific heat of water is 1 calorie per gram per degree Celsius, and latent heat of fusion, that is 80 calorie per gram. Okay. So the situation is that 50 gram of water is kept in the refrigerator and the initial temperature is 15, and it got converted into ice at 0 degree Celsius. The total duration is 1 hour. We have to determine the heat loss per minute or the heat removal per minute. So there are two steps in the process, okay, for conversion of water at 15 degrees Celsius into ice at 0 degrees Celsius. First, let me use a different ink, okay. 50 gram of water at 15 degrees Celsius is first converted into 50 grams of water at 0 degrees Celsius. So this heat loss will be in the form of specific heat, mc delta T relationship. Okay, this is the heat loss. This is the first step. Then this is specific heat. The second step is 50 gram of water which we got at 0 degrees Celsius is converted into 50 grams of ice at 0 degrees Celsius. This loss will be in the form of latent heat. Latent heat, which is called as hidden heat, because this heat is utilized in converting the entire water in liquid form into solid form, that is ice, at constant temperature. So in both the cases the temperature is constant here, but here there is a decrease in temperature, a change in temperature from 15 to 0, but here the temperature remained constant. That's why in the first case we use specific heat because there is a temperature change, and here as there is constant temperature we use the latent heat concept. So please watch the theoretical videos if you have any doubt, where I have discussed in detail these things. So we have to now calculate these values. So the first case, the specific heat loss, it is equal to first the mass of water, then specific heat of water, and change in temperature of water. This is the heat loss in the first case, which is equal to the mass of water is 50, specific heat of water is 1 calorie per gram per degree Celsius, and the change in temperature of water is 15 degrees Celsius because it changed from 15 to 0, change in temperature of 15. So it is equal to 750 calorie. Heat loss in the first step. Then heat loss in the second step is simply mass of water and the latent heat of fusion. So it is 50 gram of water at 0 degrees Celsius into latent heat of fusion, which is 80 calorie per gram. So it is equal to 4000 calorie. So total heat loss is equal to the sum of the heat loss in the two steps, which is equal to 750 plus 4000 calories. That is equal to 4750 calories. Now this is the heat loss or heat removed in 1 hour. which is 60 minutes. So in 60 minutes, 4750 calorie of heat is removed by the refrigerator, or this much heat loss happened in the water at 15 degrees Celsius, 50 gram of water at 15 degrees Celsius. So in 1 minute, per minute, how much heat loss happened? Simply we'll divide heat loss per minute is equal to the total heat loss in 60 minutes by total duration. So it is coming around 79.167, so it's 79.2 calories per minute. Okay, this is the heat loss per minute. So the heat loss per minute is equal to 79.2 calories per minute. Okay, so this is the final result. So here is another question. It is given, when a piece of metal of mass 48.3 grams at 10.7 degrees Celsius is immersed in a current of steam at 100 degrees Celsius, 0.762 grams of steam condensed. Calculate the specific heat of the metal. Then it is given latent heat of vaporization for the steam. It is given, it's equal to 536 calories per grams. Okay, so it is given that here we have a metal. Okay, a piece of metal. It has a mass of 48.3 grams. Okay, now it is dipped in a steam current. Okay, let's say it's something like this. Okay, so the steam is at 100 degrees Celsius, and this metal piece, it is at 10.7 degrees Celsius, the initial temperature. So the metal piece is initially at 10.7 degrees Celsius. So when it comes in contact with the steam, its temperature for the metal, okay, the temperature increases from 10.7 degrees Celsius to 100 degrees Celsius. Okay, this is the initial, this is the final. So the metal, it gains heat, which is given as per this relationship, mc delta T, where m is the mass of the metal, C is the specific heat of the metal which is asked, and delta T is the difference in temperature. So here the gain of heat by the metal is equal to mass of metal 48.3 grams into specific heat of the metal, which we have to calculate, into difference of temperature, which is 100 minus 10.7. Okay, this is the gain of heat by the metal. This is very important. Then this is the first part, the gain of heat by the metal. The second part is 0.762 grams of the steam, it condensed. That is, for the steam, .762 grams of steam or vapor, which is at a temperature of 100 degrees Celsius, it got converted into 0.762 grams water, that is in liquid state, at 100 degrees Celsius. So we know evaporation, condensation, melting, freezing, it all happens at latent heat, hidden heat. So melting, freezing, it happens at latent heat of vaporization, latent heat of fusion, and evaporation and condensation, it happens at latent heat of vaporization. So here latent heat of vaporization, that is involved. Why? Because everything is happening at constant temperature. The temperature is remaining constant. There is no increase or decrease. Here specific heat is involved because there is rise in temperature of the metal from 10.7 to 100. So here the steam, it undergoes heat loss. Here it is heat gain. For the metal it is heat gain because temperature increased. For steam, here heat loss happened because it got converted from vapor state to water. So the heat loss which happened, it is hidden because of latent heat of vaporization. So here the heat loss which happened, okay, the heat loss which happened, it is equal to the mass of the vapor or the steam into the latent heat of vaporization. So it is equal to 0.762 grams of steam which got condensed into latent heat of vaporization, which is given 536 calories per gram. So it is coming around, so whatever the value, let's not calculate it, okay, now there is no need, okay. So here we have to understand the basic principle of heat loss and heat gain. So the principle of calorimetry, it states that the heat gained by the metal for its increase in temperature from 10.7 to 100 degrees Celsius is the same as the heat lost by the steam, okay, the steam at 100 degrees Celsius to get converted into water at 100 degrees Celsius at constant temperature with latent heat of vaporization. So here it is specific heat, here it is latent heat from vapor to water at 100 degrees Celsius. Here 10.7 degrees Celsius to 100 degrees Celsius. So it means that this latent heat loss is equal to the specific heat gain, okay. This is for steam to water at 100 degrees Celsius. This is for the metal, for the temperature to increase from 10.7 to 100 degrees Celsius. So simply that implies MVLV is equal to MCM delta T, the specific heat of the metal. That implies 0.762 into 536 is equal to 48.3 into Cm, that is specific heat of metal, into 100 minus 10.7. That implies specific heat of the metal is equal to 0.762 into 536 by 48.3, 100 minus 10.7. So it is coming 0.0956 0.46. So if we round it off, so it's coming around 0.095 calories per gram per degree Celsius. Why? Because the information here is given in terms of calories per gram. So the latent heat of vaporization. And the temperature is in Celsius, that's why this. So the specific heat of the metal is equal to 0.095 calories per gram per degree Celsius. Okay, so the basic principle of calorimetry: heat loss, heat gain, equating it, applying specific heat concepts wherever that is applicable, applying latent heat or hidden heat concepts wherever that is applicable, and equating the results. Okay, so this is it.